FDM 3D printers are miracles of modern engineering, especially considering the fact that they cost less than $1,000. But there's a fundamental trade-off in every one of these printers that you may or may not be aware of, and that is balancing the competing interests of two engineering principles. The first is that you want to have the least amount of weight moving around as possible. That's called inertial mass. And the second is the fact that you want to have the least amount of distance between the hob gear, which is pushing the filament, and the hot nozzle, which is where the filament turns molten so that it can be deposited on your print. So there are two solutions currently on the market. The first is called a direct drive system, and that is where they take this heavy stepper motor and mount it right on top of the whole J-head assembly. That's the sort of heat sink and the hot elements and the nozzle. And the problem with that is that it's a very heavy motor that's now having to be moved around. So that's inertial mass that we don't want. But the benefit is that we do have that very short throw, just a couple of inches between the hob gear mounted on the stepper motor and where it turns molten in the chamber of the nozzle. So to remove that mass and get rid of ghosting and all the issues that come around with having a lot of mass being jerked about, there's another solution, and that is called a Bowden tube. And this is what you typically see on most of these printers coming from China. And the idea behind this is that you put the stepper motor on one end of a tube, and that has the hob gear, which pushes the filament all the way through this tube and out the other end, where it then goes into the hot nozzle. But the problem with this setup is that, especially with flexible filaments, you get a lot of slop of the filament inside of the tube. Well, first of all, the filament can compress, but it can also just sort of like wiggle around. It can sort of spiralize inside of the tube, and it just generally leads to inaccurate extrusion when you have a Bowden tube setup. So, wouldn't it be nice if there was a solution that gave you the best of both worlds, allowing you to mount the heavy weight of the stepper motor off of the moving hot end, but also being able to have a very short distance between the hob gear pushing the filament and the melt chamber of the nozzle? Well, a company called Zesty has released a product called the Nimble that does exactly that. And unfortunately, I don't have my hands on a Zesty Nimble. I would love to review that product. But in the meantime, I have DIY'd my own remote cable drive. And that's what you're seeing here. So this is the stepper motor, and it is driving a cable through a PTFE tube here, which goes to this little adapter device right there, attached to a genuine E3D Titan 3-to-1 geared extruder mechanism. Now, this took me the better part of a week to get working, and it is working quite well. I'm pretty happy with it. So stick around and I will show you how I achieved this minor feat of engineering. To start off with, I've modeled up all of the parts that I need to 3D print. And you can see this is just the flying extruder mechanism. There's my my filament runout sensor. So I'm just kind of building on that same model. So yeah, let's 3D print these parts up, and then we can get all the other components together and assemble the whole thing. So here are the parts all printed up and ready to install. But we're going to need a number of other components to go with them to complete the assembly. First of all, I've got this 3-foot length of PTFE tubing. Now this is slightly larger stuff than the usual Bowden tube stuff, and I needed that wider ID there to accommodate the cable. So this cable is from a like a curtain mounting kit that I got at IKEA a few years ago. And don't go out and buy this just yet if you're trying to follow along. We'll cover that later. We also need 2 bearings. Now these have a 5mm inner diameter there. We need 2 nuts here. And what these are for is to thread the PTFE tube into them. And this just creates a secure mounting for the PTFE tube. So that's an idea that I got from an Australian YouTuber by the name of Schematics, and I'm going to link his video down in the description. Fantastic idea, really a fantastic video. You should go watch by him. So great idea. Thank you, Schematics. We're also going to need 2 of those and 12 of those bolts. And finally, we're going to need, I think, 8 of these little inserts. Those are 3mm inserts, and those are going to go into the holes on these barrels here. We need to install this insert into the holes on this barrel. And the way I like to do that is using my soldering station hot air gun. That's this tool right here. And just turn it on. That's my soldering iron. Let's turn on the hot air and set that to 270. So that temperature is just a little bit more than the printing temperature, the melt temperature on the ABS. And that should be hot enough when I heat the insert up that it will melt itself right into the hole and secure itself nicely. So I've got my wire cutters here, my needle nose pliers, and I also have a long M3 screw, and I'm going to hold that with the pliers and just stick it in the airstream for a few minutes. Now that's going to get up to, well, hopefully 273 degrees. Okay, once I'm certain that's up to temperature, I'm just going to pull the barrel here and stick it on in the hole. Oh, a little bit tight, but it went in, so we're good. So there it is, fully assembled. One side will hold the cable and the other side will hold the shaft on the stepper motor. So now there are 4 of these M3 nuts that I forgot to show you guys a minute ago, and those get pressed into this piece. We also have the larger nut, 2 of them, which get pressed into these U pieces. To complete this side, we need to press these bearings into the top and the bottom holes, just like that. And finally, we need to thread the PTFE tube into the nut there on the U. And that's mostly just a matter of pre-chamfering the tip of the PTFE tube and then spinning it and mashing it on there, and it threads itself on there nicely. And it will not pull back out. We have one thing left to do, and that is to make the shaft. Now, I didn't show this a minute ago, but this is just some stainless steel 5mm rod, and unfortunately, it's just ever so slightly oversized so that it will not go into the bearings. So we need to stick that in the drill, sand it down just a few thousandths, and then we need to cut it to length and put a little flat spot on it so that the set screws have something to bite into. Okay, so I've cut out a roughly 40mm length of the rod, and if I put a magnet on it, it does stick. So it turns out that this is not stainless steel rod, it's actually hardened bearing rod. So because it is so hard, I find that sandpaper does not do a good enough job to bring this down to size. Instead, I'm using this cheap diamond filing sharpening stone. So just keep doing that until it fits. And now that I've got that part done, I'm just going to use my rotary tool here to grind a flat spot in it so that it looks just like the shaft coming out of a stepper motor. Okay, job done. We see one big flat spot there, just like a stepper motor, and I made 2 flat spots here on the back end just for good measure. Now I'm going to install one of the barrels onto the back end just for reference. Sliding that into the assembly, I want to leave, I don't know, about 2mm worth of gap, something like that. That'll work. To keep this from sliding back and forth while the machine is in motion, I'm going to glue the bearings to the shaft using some of this 5-minute epoxy. So here's the assembly all put together, and we can see that when I spin the one end, the other end rotates as well. Really cool. And the only thing left to do is install it on the printer and run it through its paces, do a test print, that kind of a thing. Now, before I do that, I do have to say that there is a little bit of a worrying feature or behavior from this whole assembly. If I hold this end from moving, like I prevent it from spinning, I can wind up this end. So there's a bit of flex in the cable. And so that just means that that whole cable inside of the PTFE tube is behaving like a giant torsion spring. And I'm not sure how this is going to affect things when I actually get to printing on the machine, but let's test it and find out. And this is why prototyping is so expensive, because every change you make has potential ramifications to systems which were working fine previously. So here we have the Knockoff E3D Titan extruder. It's a 3-to-1 gear ratio, and it functioned fine when the stepper motor was bolted right to it. And that's because the stepper motor, rigidly moves based on the steps that it was told to go. But when we put the cable drive here, the cable is effectively a giant spring. So we have oblong, or I should say ovalized gears on the extruder gearing mechanism here. And because of that, it's got more friction for part of the rotation than for the other part. And it takes a second for the spring to build up enough force in it to force the ovalized gearing past its, tight point. So if we look at the top here, we can see the motion coming from the stepper motor is perfectly smooth. Looks really good. But down here, by the time it gets down there, it's just super choppy. And it's periodic. Every time the gear goes around 180 degrees, it gets tight. So yeah, let's take a look at the consequence of this on the test print that I'm doing right now. So this is a great benefit to having the cable drive. I'm going to cut the power and the end effector is not going to drop at all. Watch this. Okay, so there's a tiny bit of movement, but it really doesn't compare to the constant sort of slow falling that would happen when we had all the weight of the stepper motor sitting right there. So I'm not even going to bother to finish this print up. You can see just how atrocious it is. Look at all the holes through the wall. I mean, this was the skirt that I put around the print. You can see just how blobby it is. So it's like over extruding, under extruding, over extruding, under extruding as the cable tries to get around the circle. So this is a big problem. I need to fix that gearing so that it's perfectly smooth. But I also need to come up with a better cable to drive it. This one from IKEA isn't cutting it. I'm going to take this one step further because the periodization of the over extrusion, under extrusion, which is caused by the ovalized gearing there in the geared extruder, that periodization lines up almost exactly with the periodization of the bad surface quality here on those original test prints using the 0.4mm nozzle. So I think that the bad surface quality is a result of the same problem. So that gearing, is causing it to miss the micro steps in between major steps. It just didn't have enough torque to get past the ovalized moment. And once it reached a full step, we all know there's more torque at the full steps. It would force it all the way around, and it would, but that's where the surface quality is coming from. So interesting to note. And yeah, if I can fix that problem, I should be able to go down to a 0.4mm nozzle and have beautiful prints as well, maybe even rivaling the Ender 3. Crappy quality of knockoffs rears its ugly head again, and that Titan extruder is just not going to work for me. So I want to get the genuine article, the real deal, with guaranteed quality here from E3D themselves, so E3D online. But keep in mind that these guys are in England. So with Brexit happening and with Trump in office, I'm finding it very difficult to ship things to and from other countries, specifically Canada and the UK. So you know what? I'm going to go to the official Filastruder. This is the official supplier of E3D as well as Duet products here in the United States. And it's great because if you look here on the Filastruder website, the first thing you see is the Titan pinion in metal. So obviously other people are having the same conclusion that I am, that gear is just terrible and you got to replace it with metal. So look at that. That's going to be great. So potentially that solves all of my problems. But just in case, you see my cart here, and I'm actually going to order a whole Titan extruder as well. So if the metal gear doesn't solve the problem, I'll have the whole extruder. And if it does solve the problem, I'm going to put that extruder onto another one of my 3D printers. All right, it's been ordered, so in a couple of days when it gets here, I'll finish this build. And my parts have arrived from Filastruder. So here's that $4 metal hob gear. I'm sorry, it's not a hob gear. It's a pinion gear to drive the knockoff Titan extruder. And here is a genuine Titan extruder. Now I gotta say, I feel a little bit ripped off because two of the pictures for this listing showed an E3D heatsink similar to this. This is a Chinese knockoff, but basically they showed this part. And as you can see, there is no heatsink included in this kit. So I went back looking at the listing, and sure enough, there is a picture with just these parts on there, but nowhere does it say, you know, hey, heatsink not included. So I thought I was getting one of these. And yeah, you know, I know it's made in England. It's made in the West. All parts are made in the West. But still, $60 for this plastic. $65. It's expensive. Like, it's expensive. And as it turns out, I absolutely must get the genuine E3D heatsink, because you see there's all this play in the Chinese heatsink between the genuine article and the Chinese knockoff. So that won't work. Dang it. I've removed the knockoff Titan extruder, and here's the pinion gear installed on the shaft. This is the plastic pinion gear. And you know, I put my my caliper here onto the gear in a number of spots, and you know, I didn't get too much variation. It went from like 11.75 to about 11.9. So about a 0.15 millimeter difference to the outsides of those teeth. Now, I'm not measuring in the valleys, so I really don't know where the asymmetry is coming from on this gear. But, you know, let's hope that the metal one solves our problem here. I think I have to eat my words and take back almost everything that I said bad about the knockoff E3D Titan extruder here. This might actually be the better product. So, the spirit of open source, as I've said again and again, and I will say it here again, it's not to give away your product for free. I know as consumers that's what we want to think, that we get stuff for free, but the point is that we're all working on this together and that we all feed off of each other's knowledge, and so we put it out there. We put the source files so that somebody can improve upon it, and that looks like exactly what this Chinese company has done. To start out with, check out the pivot mechanism. So this is the tension arm, right? And it pivots from right there. This is the knockoff. On the original E3D, we see that the pivot mechanism relies on the shaft from the stepper motor. Well, who's to say that that shaft isn't bent? And also, there's no bearing there. That's a bushing. We're relying on the plastic to just sort of rub around on that shaft, so that can wear out. Whereas on this design, there's not going to be any wearing out because there's not a constant rotation on that pivot point. And the other thing that's improved upon is weight. So we don't want to be moving too much weight. And this knurled knob, which is nice to have, a little hand adjuster, although you don't adjust that very often, right? So we don't need all that weight to be thrown around with the end effector. Whereas on this one, there's just a very lightweight little screw. So I think this might be the better product. The clear distinction between these two, the thing that separates the original as better at the moment, is the fact that it comes without this plastic drive gear. It comes stock with the metal pinion gear for putting on the stepper motor. Now the only quality issue is how good they made the plastic large gear. So if this gear is ovalized or imperfect in any way, you're going to have tight spots in the rotation. Whereas it looks like they really made it perfect here on the original. I have installed the genuine E3D Titan extruder, geared extruder on the machine, and let's see if it makes any difference. Yeah, it is noticeably smoother. So that means that the quality of the large plastic gear is quite a bit better on the original genuine E3D Titan. Okay, first print with the genuine E3D Titan extruder. It appears to be going quite well. Looks really clean under there. Looking up here at the top, we see the stepper motor very smoothly making its motions. But if we follow that cable down, we see right here, it's a little bit choppy. It's not nearly as bad as it was before, and I don't know where that choppiness is coming from. Could be the ovalized gearing, could be a cable that's not perfectly straight. But at any rate, it is producing a print that's a whole lot better, so we'll take a look at that here in a second. And here are the test prints. This is the one we've already seen with the stock Tevo Titan extruder. This is the stock Tevo Titan extruder with the metal pinion gear. That's this thing. And here is the E3D Titan extruder. So just so much better on the quality. Anyway, let's take a look at these up close. I think the most telling thing is the skirts. So there's a little difference. There's a little difference though. This one's a little bit better as far as the blobbiness goes. And that's just, you know, every full rotation it made a blob. Now if we see this one here, there's still some slight blobbiness, but it's about twice the period. So the periodization changed for the blobbiness. And the final print looks really good. The interesting thing, I don't know if I can get that to show up on camera, is that it has a surface quality now. Even though this is the 0.8 millimeter nozzle, the surface quality is very similar to what we saw on the 0.4 millimeter nozzle before. So it appears that the E3D Titan is worth the extra $45. I mean, you're getting, what, 3 times better print quality at 6 times the price. So it's not a bargain, but it is the best. Yeah, so I'm going to stick with this one for sure. Now, I think the only thing I can do to make it better still, and there is still room for improvement, is to get that titanium solid core wire instead of the IKEA cable to drive the remote extruder. While I'm waiting for the titanium wire to arrive in the mail, I decided to reinstall the stepper motor into the direct drive position with the genuine E3D Titan extruder. And I used it to print a test print with a 0.4 millimeter nozzle, so I reinstalled that as well. And that test print is looking good. But I'm not going to show that to you guys until I've got the titanium wire print to compare it to. My wire has come in the mail, and what you're looking at here is the 3 sizes of grade 5 titanium alloy. Now, I ordered grade 5 because it's superior to titanium in its springiness, and titanium is already known as a very springy material, so this is going to be just about the most superior cable material that I can find. Now, it's all of this is pretty flexible. The small one, of course, is the most flexible, but it's also going to be the most springy, which I don't want. So I just need to figure out which one, the small, medium, or the large, is the best combination of flexible, because it needs to be flexible, right? The extruder moves. So it needs to be the best combination of flexible and yet not too springy in the torsional way. Now I do have to say that this titanium wire isn't perfect. I don't know how many of you have seen the glasses frames that come with titanium wire, and it's unbelievably springy. You can wrap it around your finger and it springs back into the exact shape it was in originally. So I would love to get my hands on some of that. I don't know how it works. Maybe it's an even more specialized alloy, or maybe it's been heat treated or something. But with this wire, if I overstress it, I can bend it to where it does not spring back into shape. So I just need to be careful that I don't do that. I can't overbend the cable drive. So all done, titanium wire, remote drive, running the end effector with a nice print going, and we see just how smooth the movement is right there on the at the end of the titanium wire. So gone are all of the springy problems, although it is still a spring, just a much stiffer spring. So it appears to be printing beautifully, but we'll take a look at that when it's done. So here are the test prints, and they look amazing. This one here is the direct drive, and we can see, I mean, we need to compare it here to the print from the Creality Ender 3, because it's darn close to the same quality. The only real difference that I'm seeing is the ghosting, which is pretty severe, but I got that ghosting to be eliminated by over-tensioning the trolleys. So clearly if I can get the tension right on the trolleys, the ghosting will go away. So I'm gonna call it and say that I can get the same print quality from this printer now that I can get from the Ender 3, which is awesome. So this is now officially my best printer, hands down. But this was the direct drive, and I wanna run it with that cable drive. And we can see this print looks pretty close, almost the same, except that there is some slight banding. Now, let's see if I can get that to show up on camera. Can you guys see it? There's just some sort of horizontal lines. The layers don't always come out perfectly. And I don't know what would cause that. It's kind of a mystery to me why the cable drive would cause banding. Now it is faint and I'm sure it would just disappear once I start printing with the 0.8mm nozzle again. But you know what, if I'm chasing perfection, that's something that I need to figure out about my cable drive system. Okay, so the biggest conclusion that I can draw from a whole week's worth of experimenting on this thing is that the E3D Titan extruder is worth the money. Now, you guys heard me griping about how expensive it seems, and I did a little reflection on that, and I realized that that's just me reacting to what seems like a high price in comparison to all of the components that I get from China. But we've covered before about how China doesn't beta test and they don't quality control, and that's why their stuff is unreasonably low priced. And there's a reason that cheap is a synonym for low quality. So if you want the high quality, which results in the undeniably better prints, the better quality prints, you have to get the E3D. There's just no way around it. Now, something to think about is that if you are going to buy a Zesty Nimble, you know, so that you have the cable drive like I'm using, you don't need to get the genuine E3D because you won't be able to use the Zesty Nimble with the gear reduction. The Zesty Nimble is a extruder assembly and cable drive all in one. So you'll have to go with their solution and you will lose the gear reduction, which may or may not be a bad thing depending on how springy their wire is. I don't know what their wire is made out of. So the gear reduction helps reduce the amount of force going through the spring, which limits the amount of actual spring effects that you have. So food for thought. I need to get my hands on a Zesty Nimble. Zesty, if you guys want to send me one to test, I would love to do that. But in the meantime, I'm pretty happy with this solution that I've come up with. And it's something that Zesty does not offer. It's a direct bolt-in replacement for anybody who's got a direct drive extruder mechanism. You don't have to get rid of your current hob gear, your geared assembly, whatever it is. You just mount that stepper motor off-site and it's still driven the same. So you just reduce that weight from your printhead, which is pretty cool, I think. But there is definitely some more iterating that I need to do to get the design finalized. Like, it's not quite right yet. It's very functional, proof of concept, good to go, but you know, I still have some work to do. So make sure you click all the good buttons, the subscribe button and that bell, if you don't want to miss the future videos where I show the upgrades. And yeah, that'll be it for this week. I thank you for watching. See you next time.